This process starts out when the signal molecule activates the G protein receptor. The transduction pathway will now begin. An inactive G protein connects to the G protein-linked receptor. It then becomes activated with the addition of 3-phosphates, or GTP. It then signals adenylate cyclase and transfers a phosphate to its ATP. This makes CAMP. Now there's a GDP on the G protein. The CAMP signals the protein kinase. It will then signal an inactive enzyme, which will become active. Then the cell will respond. Our response is the release of calcium ions, which it's important to keep a leveled concentration for cellular communication. In this form of cellular communication, the signal protein activates the tyrosine kinase when it touches it in the plasma membrane. At this point, it is inactive, but it starts the process of the transduction pathway. ATP starts to break down into ADP, where it loses 1 phosphate. These phosphates are donated to the tyrosine kinase, and this makes it active. Once this is active, the cell can now produce its response. In cystic fibrosis, the cell goes through the normal G protein receptor system. When cellular communication goes correctly, chloride ions are released among the membrane. But if the pore is closed, they can no longer do this, which will cause an infection over the pore. Cystic fibrosis is the buildup of mucus, bacteria, and other infections within the lung. So this can cause serious pain and early death in adolescents and kids. There isn't really a cure for cystic fibrosis, but there's CFTR, which helps people with a certain protein mutation in the membrane, but it doesn't target all protein. It only targets proteins that have a certain mutation that scientists can target. Now, there's also other treatments, like you get a lung transplant, but not everyone can do that, or you can use antibiotics and medicine or massaging techniques to lessen the pain.